the transfer function. And firstly, we would like to talk about the circuit transform. And what is the object to perform circuit transform? The objective is that we can find an equivalent circuit with different topology, and we can change interchange 40 mole to current mole, or change from 40 mole to current mole, or current mole to 40 mole. Or we can interchange. And why we need to interchange? Because I will say that later. And maybe it can be used to obtain a denial function. For example, original transfer function Ts, and maybe we would like to find 1 over Ts. Why? Because maybe because we transmit a signal, and the propagation process, maybe we can model it by Ts. If we can tie 1 over Ts, then the transmission effect can be cancelled. Therefore, so we can this is maybe we somewhere maybe we would like to have the inverse transfer function of the circuit with the transfer of the original inverse, and maybe we would like to have the complementary. For example, originally Ts, and we would like to have the transfer function of 1 minus Ts, and we can use circuit transform to derive new useful circuits and the high performance circuit, such as the circuit with lower sensitivities, because we would like to have a circuit have a specific function, but we don't like that some component error will affect the system. Therefore, with lower sensitivity, then the system will become stable. Okay, so and just before I'm talking about the voltage to current signal transform. Why we need current mode signal transform? Because current mode signal operation, because maybe they have some potential advantages. The advantages such as the higher bandwidth capability, higher operation speed, because we know that each wire will have a resistance and a capacity effect. Therefore, if we consider the voltage signal, then we need to consider the charge and discharge, because we charge the node voltage and the node voltage, we charge the capacitance between the node that we are considering. Therefore, because we know that the wire have a resistance and capacitance effect, so if we would like to change the voltage, we always need to charge the capacitor or discharge the capacitor. However, because the capacity effect cannot be, it will be always exist. However, if we consider the current mode circuit, because the parasitic inductance will be a little smaller, so maybe it will not. We don't need to consider it for the frequency we are interested in. And another advantage that they will have a greater operation dynamic range, because we know that the technology that the supply voltage is lower and lower. So it means that the voltage string will become smaller and smaller. But if we consider current, maybe we don't have this effect need to consider. And I said that you will have higher lower circuit complexity. For example, if we would like to perform the addition of a calculation of a signal, this is an operation amplifier based inverting amplifier. So we need circuit to perform the voltage signal addition. However, for current, we just connect together. It will perform the addition of current signal operation. So we don't need other resource we don't need other circuit to perform that. We just connect together, then it will perform the addition function. And the current mode maybe will be much faster as compared to 40 mode circuit because I said the parasitic capacitance present in an L circuit must be charged and discharged. with the changing voltage level. And the current mode level, if we can see the current mode circuit, a change in current level is not necessary, accompanied by a change in the voltage level. So because we need to consider parasitic capacitance, but maybe we don't need to consider parasitic inductance. That's why we maybe sometimes we need a current mode circuit. Maybe you have some potential advantages. Okay, then I will introduce the pathologic circuit elements. What is the pathologic circuit element? This is the so-called numerator, and the numerator is the so-called pathologic element. We can find that this is a symbol for numerator, and this is a symbol for numerator. We find that the potential between the V1 and V2 are the same, and the current flow into this element is 0. So this is the definition of numerator. And for numerator, the voltage is arbitrary, and the current will be arbitrary too. But however, the current I1 and I2 have different, have a minus relationship. And we can compare with the open short circuit. We can compare it. This is so-called short circuit. A little different, and a little similar, because you can find that short circuit means this one, this property, plus this property. And for open circuit, it will be this property, current 0, so this property add this property. So they are a little similar to open circuit and short circuit. And if we combine these two elements together, we call it nuller. The nuller is the only active element which Telgin discussed. It is a minimal size set of element in 1945, 54. It can use to model the linear and nonlinear driving point impedance of transfer characteristic. And why we need the pathologic circuit elements? Because their capability to model an active circuit independently of the particular reaction of the active devices, and the simplicity with which nodal or loop analysis of the circuit can be carried out, and permit the generation of a number of equivalent idealized circuits from which the best practical ones can therefore be selected. And we know that we need an amplified circuit. Why? Because in the environment, when we measure the signal, it's just a mini voltage, the mini level, or maybe 10 millimeter level. Almost the voltage level. So we need an amplifier to amplify the signal. And normally we have 4 types of amplifier. The voltage input, voltage output, this is a voltage amplifier. Current input, current output, this is a current amplifier. And the voltage input, current output is a transconductor amplifier. Or the current input, voltage output, this is the resistance amplifier. So this is the basic 4-type amplifier. We find that either voltage input or voltage output, either voltage input or current input, either voltage output or current output.
I'm sorry, Professor, you have 5 minutes. I'm here, left here, Intan here, also.
Okay, so
we still have 5 minutes later, okay?
Okay.
Thank you.
So we the nuller element can be used to model, because I said that we have this 4-type amplifier. We can use the element to model this 4-type amplifier. And we can see that this is the OP amplifier. It can model by the model here. This is the OTA, or current conveyor. It can model by the nuller elements. And the current mirror and voltage mirror, it can model by nuller elements. This is the floating mirror. It can be used to model the differentiation, because we nowadays the circuit we prefer the differential input, because the differential input circuit you will have the higher noise immunity function. So we prefer the differential input or differential output circuit. Then we need need such a skin. And in 2002, there are 2 additional mirror elements have been proposed. And we can use the model. You can see that the pathology element can be modeled at devices. And even it is the high frequency small signal MOS transistor small signal model. We can use the pathology element to model the small signal model of transistor also. And the short circuit and open circuit, we can model it. These are open circuit and short circuit. And okay, I will, in brief, so I would like to introduce what is circuit transform. You can find it the circuit transform. I will introduce it can be applied to linear circuits such as filter, amplifier, oscillator, impedance simulator. And I will introduce a joint transform, dual transform, complementary transform, inverse transform, and other transforms. This is so-called a joint transform. So we can find that we just the 40 input change to current output, or the 40 output change to current input, and the passive element remain the same, and the numerator interchange to numerator. So it can be found. This is the related papers. And we find that because I said that this is the OpenMI model, it can be represented by numerator and numerator, and we judge interchange. We just interchange, and the 40 output become current input, 40 input become current output. Well, then the transfer function of VO of V in will be the same as the IO of I in. So it means that the 40 mole become the current mole, or the current mole become the 40 mole. So this is an example. We model this active element by pathology device, and we can perform the joint transform to obtain other oscillator circuits. And this method can be applied to multi-input, multi-output systems. And this is another example. It can be applied to multi-input, multi-output systems. And the second transform is the dual transform. The dual transform is that based on this principle, admittance become impedance, voltage become current become voltage. So we just interchange G to R, C to L, L to C, numerator and all keep the same. Then we can obtain the 40 transfer function to current transfer function. So you can see that this is a duality, and after the dual transform, you can find the original transfer function VO of VI, and after the transform, we can obtain the circuit, and with the property of IO of I, and their transfer function are the same. And this is another example apply the dual transform. Just before we talked about the 40 mirror and the current mirror and the 40 mirror, and they can be replaced by numeral model, and we know that you can find that the register must be the same value. However, because for IC technology, we can obtain a matching device easily. So even the value are the same, but it can be realized by using IC technology. So this is example. Original, this is a oscillator, and this is a simulated waveform. This is the oscillator. And then we perform the circuit transform, the dual transform. We can obtain the other oscillator, and it can be oscillated too. And this another example is a multifunction filter. So this is original filter proposed by. It can be found in this paper. This journal paper. And after the circuit transform, you can see that original is the voltage output over voltage input, and after transform it become current output over current input, and you can find that the transfer functions are the same. They have the same field functions. And this is a so-called complementary transform. You can find the transform in the textbook of microelectronic circuits. It's used to this original transfer function, and if you desire to obtain the 1 minus t transfer function, you can use this way. I just want you to know that how to maybe we just perform circuit transform, and we can obtain new circuits, and the circuit with the desired function. And this is so-called inverse transform. And the way to obtain this has been published in 1997, 1998. It's just used to, because this is an active device, we model this device by numerator and denominator, and we just interchange the input with output numerator. After that, we obtain this circuit. And this new circuit, the transfer function is the inverse of original transfer function. Namely, if the transfer function of this circuit is t, then the transfer function will be 1 over t. So this is so-called inverse transform. And this inverse transform can be applied to multi-input-output circuits. This is a 2-input, 2-output circuit. And we perform the inverse transform, and we obtain the circuit have the inverse transfer function of the original. And we extend the inverse transform to other pathologic devices. It has been published in 2005. And we apply extended inverse transform. You can find that the inverse, this is original frequency response, and after transform, we obtain this is negative and the phase response for obtained circuits. So this is another example. So it just proves that the inverse transform with different pathologic elements is useful, and it can be realized. Similar, this is another response. This is we change the filter and to obtain the inverse transform. You can see that this is original frequency response, original phase response, original the negative response, and we obtain the inverse transform. It can be found from the frequency response. Okay, so there are some other ways. Well, however, I would like to have a conclusion because you can see that we use this has been published in 2014. We combine complementary transform and the inverse transform to obtain new circuits. And what's the function for the circuit transform? I will conclude it because the pathologic element can be used for circuit transform to derive equivalent circuit, current mode circuit, inverse circuit, oscillator, and low sensitivity circuits. The effective skill of circuit transform is that it can be applied to wider spread circuits for different objectives instead of a single unique circuit design. So this is the objective of the circuit transform. Thank you.
Thank you. Please give applause to Professor Wang. Thank you, Professor. So for the question and answer, we will do it after Ms. Ernie's presentation, okay? So the second keynote speaker is Associate Professor Ernie Puspanantasari Putri, our own lecturer in Untak Surabaya. She was born in Yogyakarta in 1971, and she completed her doctoral degree in industrial engineering at Khon Kaen University, Thailand in 2019. And her master degree was completed at Catholic University Leuven, Belgium, graduating in 1999. And her bachelor degree is in industrial engineering at Untak Surabaya, graduating in 1999 also. 1995, sorry. And she was the recipient of 2 types of Thai scholarships to complete the doctoral programs, and the recipient of a scholarship from Belgian government scholarship to complete master degrees. And she has been a permanent lecturer at UNTAK Surabaya in Industrial Engineering Study Program since 1997 until now. So, wow, longer than me, of course. And she had published many scientific articles in various national and international journals and presentation at various national and international forums, among other things. And please welcome Ms. Ernie to present your speech about Tayeng Batik, a new innovation for making motifs on batik using iron rust stains. Please welcome Ms. Ernie.
Thank you, Dr. Intan. Please. Good morning, everyone. Nice to meet you all here. Semangat pagi. Okay. We call in Indonesia that it is should have a spirit morning, because when we get up in the morning, we always fresh spirit, something like that. So I will quickly to present my paper, my presentation, please. We call, the title is Tayeng Batik, a new innovation for making motif on batik using iron rust stain. You know who the famous, the #1 people in Indonesia? Our president, Jokowi. They using batik that I use also, and I look for Dr. Alexander to wear batik also, right? Oh, stand up, please. Look at the batik. So batik is really the heritage of Indonesia. Everywhere in the world know it. Batik is one of the pride of Indonesian cultures. This pride has increased since UNESCO designated batik as a humanitarian heritage in masterpiece of the oral and intangible heritage of humanity on October 2, 2009. So a few days ago, we celebrate the batik in the world on October 2. So UNICEF's recognition of batik as Indonesia culture heritage is an extraordinary acknowledgement. And then this is the technique to making batik. There are 4 techniques: frightened batik, painted batik, stamped batik, and printed batik. So we can see in this picture for writing batik, this is the process to making batik with writing with hand. So we can batik made using chanting with wax as the main material. So we call this one is chanting. And then another one is painted batik, like the painting, yeah. This is the way to making batik with painting. So really handmade. And then the next one, this is a stamp batik. Yeah, stamp batik is more quickly, so because we don't have really the hand making, so just stamp and more quickly, something like that. And then the next one is the printed batik. Yeah. So this is the 4 process to making batik. And then the next one, we will know about the Tayeng batik. Yeah, this is I think it's not many people know. Yeah, because this is the new technology. The founder is Mrs. Firman. So as we know, this is the batik Tayeng is made by employing the color of rust iron as an accent on the batik textile motif. Tayeng means rust, so we call the batik Tayeng. Tayeng is mean in English is rust, therefore this motif was later dubbed Tayeng batik. This is the story, the name of the batik Tayeng. So we call this, so if we, if we do this one, this is the knot of the rust iron. This batik look different and unique due to the combination of batik motif with iron rust color accentuation. Now, this is the basic for the block of the iron rust, and then after we making with the one of, this is with the written batik, so the batik become beautiful like this picture. And this is the process, how the way to make the iron. Chemical process. Just next. And then this is the process step for making tayeng batik. The first. This is the process which we have the iron and then just put in the carton, yeah, something like this one, and then with process give some chemical, maybe salt water, and then we wait for a few days and become like this. And then one we can see before and after, something like that. There is some block of the carton, and then after that it is the final batik, tayeng batik. So we will see how the process to making batik. Can you play the video? I just know to in drill, so you can imagine well what the step of process to making batik. Just find in this bahasa Indonesia. I hope the participant from Taiwan, Russia, India can understand.
Monggo guys, dipilih-pilih kainnya. Mau yang jenis batik tulis atau batik cap, semuanya bebas kalian pilih deh. Tahu nggak sih guys, kalau dilihat lebih detail, terdapat corak khusus berwarna coklat kemasan yang ada di dalam kain batik ini. And you know what? Corak nan indah tadi ternyata berasal dari kawat berkarat ini loh guys. Ahai, kalian wajib percaya kalau Kak Ojib yang kasih tahu ya. Secara info A1 yang kalian dapat ini langsung dari sumbernya. Tak lain dan tak bukan dari Pak Firman, seniman batik tayeng dari Surabaya yang menemukan teknik pembuatan motif tayeng pada kain batik.
He is the founder of tayeng
guys,
batik.
Sebagai mantan dalang yang beralih profesi menjadi pembuat batik, Pak Firman mulai belajar membatik di tahun 2012. Inovasi untuk menciptakan karya baru dalam ragam seni membuat batik lewat karat yang terdapat pada kawat atau bahan-bahan logam lainnya, ia lakukan secara spontan agar produknya dikenal oleh masyarakat. Korosi atau sering kita kenal dengan karatan ini sering membawa dampak buruk bagi sebuah bahan material, misalnya besi dan logam. Karat pada besi berupa zat yang berwarna coklat merah, reaksi secara kimia melalui interaksi zat seperti air atau udara, membuat karat pada besi akan mengelupas dan terjadilah proses korosi itu. Merubah yang rusak menjadi karya seni yang indah, kain mur yang biasa digunakan sebagai dasaran kain batik akan direndam bersama kawat berkarat selama 1 hari 1 malam guys. Tujuannya udah jelas, untuk membuat karat kawat menempel pada bagian kain sehingga tercipta motif-motif yang artistik. Dengan ditutup menggunakan spons, kain akan ditimbun sampai motifnya berubah menjadi pola yang sempurna. Dalam proses ini, media berupa tempat untuk membuat pola harus dipastikan tidak boleh tercampur dengan air terlalu banyak, karena akan mempengaruhi hasil akhir dari pola karatnya. Guys, meski tak bisa diklaim sebagai orang yang menciptakan pola karat pada kain lewat batik tayengnya, nama Pak Firman sudah dikenal sebagai pionir inovasi kain batik yang unik di Indonesia. Bahkan karya batik tayeng ini sudah mengekspansi pasar luar negeri loh. Ini loh guys, motif asli dari kain yang sudah melalui proses pencampuran karat. Guratan-guratan khas karat atau dalam bahasa Jawa disebut tayeng, menghiasi kain yang sekilas udah mirip motif batik pada umumnya, berwarna coklat kemasan. Jangan salah ya guys, proses tadi masih jadi proses awal pembuatan kain batik tayeng ini. Pembuatan motif yang terdapat pada batik tayeng ini tergantung oleh pesanan si pembeli guys. Pak Firman hanya mempatenkan kain tayengnya aja. Selanjutnya, kain akan dihias dengan berbagai jenis motif batik khas Indonesia. Lewat proses batik cap atau proses nyanting, atau yang biasa dikenal dengan proses pembuatan batik tulis, motif batik yang beragam dibuat di atas kain tayengnya. Tenang guys, proses pembuatan motif tayeng pada kain tidak mempengaruhi ketebalan dari kain murinya loh. So, jangan takut ya, meski kena karat, kainnya tetap tebal kok. Kain batik akan lebih indah kalau diberi sentuhan warna sesuai dengan asal daerah batik itu. Lewat proses pewarnaan ini, pembuatan kain batik yang indah hampir selesai ya guys. Nama batik tayeng belum familiar bagi beberapa penggemar kain yang sudah menjadi warisan budaya Indonesia ini.
Yeah, this is the step of process to making batik. So, can understand very right? I will continue for my just a little bit. Go to my slide, please. Nah, this is I just saw the kind of the motif batik Tayang. We call this is color pooling and soga motif, and then this one we call the Tayang batik mati of traditional within 80 bm and writing batik with Tayang background, and then Tayang batik with kawong and traditional rujak sente motif. This is because many kind of batik. Okay, thank you very much.
Okay, thank you, Ms. Ernie. Let's give a round of applause. It's very interesting. Okay, so both of them are actually from different department. Jadi mereka dari departemen atau jurusan yang berbeda. One from electrical engineering and another one is from industrial engineering. So that's why the topic of today are quite different. But is there anyone in here who want to ask questions? Even from the electrical engineering students and mechanical engineering students, or maybe some of you are from industrial engineering, please raise your hand. No? Oh yeah, sure, okay.
Check. My name is Mustafa Saif Ardana. I am from the Department of Civil Engineering. I want to ask about the Tayang batik. Is there any side effect of the rust in the body? Because from as far as I know, rust is not very good in human health. So if there is any side effect of the rust, please give me some explanation about that. Thank you.
Thank you. That's a very good question. Okay, one more, and then later we will go to the answer. Is there anyone who want to ask? No? Okay. I have questions for Professor Wang, but maybe, Bu Ernie, you can answer first, okay? The question of our student. Okay, so the question is that, you know, the rust of the iron is, we understand that it's quite not really good for human health. So is there any bad impact on the human when we wear the batik Tayang?
Thank you very much for the question. Actually, until now, it's not yet discussed because this one is still the new innovation, but not. It is the founder is from Surabaya. Yeah, so I think it's just a few years ago, and not many people still not yet making in general like another batik. So I think until now that I read in newspaper or literature or article in science article, until now it doesn't have impact. Maybe because this is they try to make the friendly environment. As we know, rust is not good. That's why the symbol of the batik Tayang is something that dirty, something is bad, but they can have something is a beautiful thing. That's why. This is the slogan that Mr. Firman give the idea how rust become a nice thing to be batik. Okay.
Okay, so the answer is basically the process is trying to be very environmentally safe for humans. Yeah, okay, thank you. And so Professor Wang, one of our lecturer actually chat me and then asked me to ask you. So the question is that because most of us here are very new with your field of study. So what we understand about the electrical network transfer functions is that the question is what are the benefits of your research results on the progress of communication, media, and tools? Because as we understand right now that Internet of Things become the new way, right? And you said that the function can lower the sensitivity of the network itself. So can you please explain about it? Thank you.
Actually, the technique I just introduced, the function can be used as to filter out the signal. It's about signal processing. So maybe whenever we obtain the signal and we would like to remove the noise, of course we must judge first that is the noise is high frequency or low frequency. So filter the main function of the filter is to obtain the denial function, denial signal. And I said it can be applied to oscillator. We know that oscillator is a circuit that can be generate signals. For example, it can be after some more further processing, so it can generate a clock that can be used for digital circuits used. Yes.
Okay, thank you. So maybe I will explain it in simple in Indonesian. I'm sorry. So jadi penelitiannya itu adalah tentang tujuannya untuk membantu signal processing. Jadi untuk implementasinya itu bisa ke elemen-elemen sirkuit gitu ya, yang nantinya bisa membantu untuk sensitivitas dari elektromagnetiknya gitu, mungkin sinyal elektromagnetiknya gitu. Okay, that's your answer in Indonesian. I just help our students to understand more. Okay, so another question is for Miss Ernie. What is actually the meaning of batik Dayeng? Maybe you can explain to our foreigners friend here, because this is very new to them. So the meaning of batik Dayeng. Oh yeah, maybe do you want to have a question? Okay.
Okay. Good morning, everybody. And just a complimentary, just first keynote speaker, it just mentioned about the circuit design. Circuit design is a benefit for the, especially for the IC design, the fundamental, is important. And also that can the speed you designed some of the circuit. And also, we just say not only for the signal processing. We know signal processing especially remove some noise, but this one you can speed. If you use the correct model, so Professor Wang mentioned that about many models about some of the circuit design, and also it used some of the mathematical transform, especially for the Laplace transform. Transform is a very important tool, and also include that if next stage you need to design like high speed IC design or VLSI design is important for this basic idea. I just say the benefit about this topic, especially and design. We just say the high precision IC, especially is reliability. Also, you need to check again. So if you have some philosophy of the circuit design, you easy to check. And also, we can final design which is a high reliability percentage IC. Okay, that's a complimentary for the Professor Wang. Okay.
Okay, so I'm sorry, wait a minute. Because this is at 10 a.m., we have to sing our Indonesian anthem. So please everyone stand up for a minute, and then we're going to sing for the Indonesian anthem first. related? Okay, Dr. Alexander Vladimir, please.
Yeah, thank you. I have a question to Professor Wong. Yeah, a very interesting talk, okay, you as expert in this field probably will explain a bit better. Nowadays, artificial intelligence is coming to our life very rapidly, and of course, it's coming to your area also. So, and the traditional way to design the circuits is based on mathematics, predefined functions, and after that, the preparation of a chip. But nowadays, we deal with a new model. You have like a black box, and it can be trained, self-trained, and then it try to fit the response to some. For example, you have a frequency filter, and this system can be trained by itself to fit better the parameters to the frequency filter, and this can be quite difficult shape, but the system can self-train, and you don't need so much mathematics, predefined mathematics, so you don't predict anymore mathematically first, but you can give this possibility to system itself to be trained. So do you know, I'm sure they're existing, but probably you as expert in this field explain a bit more. Are these systems already existing? Are they already developed as circuits, chips? And probably, have you heard about this sort of electronics, new modern electronics? Thank you.
Okay, thank you, Dr. Vladimir. Please, Prof. Wang, you can answer the question.
So your question is about, you say, I mean, the component value will be variance, right? Yeah, yes, because I said black box.
Yes, it's a neural network which is self-trained, and then you have some response, for example, frequency response.
Yes.
So it's another concept behind. So you don't have a predefined circuit first, but the system can be trained itself for your purposes, for example, for filtering of something.
Actually, so you because
they exist already in several fields. I know for spectroscopy they exist such systems. I'm sure they exist in electronics, but I just want to ask you as expert. Probably you have heard about them.
What you said is there any other specific implementation about your topic? Because he wants to know your expert information about the electrical things.
你说有些系统不需要你的 model 的话，他们可以追踪 看法。
Actually, nowadays I think your concept about some AI embedded, but I think maybe if you concern AI, then you must use the software skill to I think you need a software skill to deal with. So actually, I focus on the research about hardware, so I'm not so familiar with the AI technique. Let me think about it. But however, maybe we can have if the denial function, maybe we can detect the change of the needed function, so then to alter the component values to obtain the denial function as you want. I think so. Sorry, it's because I'm not an expert.
Thank you for the answer, Professor Wang, and thank you for the question, Dr. Vladimir. So maybe Bu Erni, the last question for you that hasn't been answered, yeah? Is there any meaning in the name of batik Taeyang?
Actually, I already explained, but I will explain again because rust is a dirty thing. So inside dirty thing, we can create something that have a high value product, something like that. So because if this is the start when making the writing batik, when they hang out the batik in the iron, then there is have the hull or knot of the iron. So this is make the destroy of the batik. So it is will be written batik, and this is will be have the batik have a low value, and the price become low than the good quality. But the FHENMA said that this must be the nice thing. So with the create that the reject batik become more beautiful and accepted people and have the high value. That's why this is the meaning of the batik is inside the something that bad, we can still create something that become the new or the nice or innovation batik and have the high value, something like that.
Ah, I see. So the meaning of batik Taeyang is actually the bad things from the rust actually can become a beautiful things, become a clothes that we can wear every day. Isn't it right?
Right.
Okay, that's good. Okay, so because of the time, we are very sorry that we have to end this sessions. And thank you again for Professor Wang. Thank you for Professor Ernie for today. And please give a round of applause for both of our speakers, everybody. Okay, time and place, I give you to the MC again.
Okay, thank you. What a great inspiration, explanation from our speakers. But maybe before we close the agenda, we can take a photo together. How about that? Okay. Please, all the participants, we can stand up together and take the photo together. And also the keynote. Okay, please stand up and give a big smile. Iya, sana. Ke situ loh, tengah-tengah situ. You can move there.